Hello everyone. In this lecture we will go with the concept about the virtual function and the virtual table and virtual pointer. Now we will just to revise the virtual function means what? Virtual function is a member function which is declared within a base class and redefined by the derived class. That means simply the way. This is the important line. When you refer to a derived class object using a pointer, means when we create the base pointer like base class pointer, when we create the base class pointer, that means simply the class A as a base class, and then we define A as a pointer, right? This pointer object is a base class pointer object. When you refer to derived class object using pointer or reference to the base class, this is a pointer of a base class, and then again we define another class as a B as a derived class of a inherit from the A class. Then we create the B class pointer, that is B class object obj, and we assigns ptr is equal to derived class object. Derived class object means we assign the address of derived class object to the base class pointer and we access it with the base class pointer. Here derived class object, when you refer to derived class object using pointer or the reference to the base class, you can call virtual function from that object and execute the derived class version. Means with the help of that pointer we can call the derived class function if we define a function as a virtual function under the base class. We will go with the simple example. Then virtual function ensures that correct function is called from an object regardless of the type of reference used for the function call. Virtual function ensures that the specific function of a body is called as per the logic. They are mainly used to achieve the runtime polymorphism. When we use the virtual function and related to the pointer, assigning the derived class object address to the base class pointer, then when we use it, when we define any function as a virtual function, function are declared as a virtual with a virtual keyword in a base class. The resolving of a function call is done at runtime. That's why it's called as a runtime polymorphism. Rule for virtual function: cannot be a static, cannot be a friend function of another class. If we define any function as a virtual, it's cannot be a static and cannot be a friend function. Virtual function should be accessed using pointer or reference of a base class to achieve the runtime polymorphism. Prototype of a virtual function should be the same in a base class as well as derived class. Always define in a base class and overridden in a derived class. It is mandatory for derived class to overridden. In that case, base class version means if we not mention the derived class with the overridden function, then it automatically called the base class function. Class may have the virtual destructor, but it cannot have the virtual constructor. We will know about the virtual constructor and destructor in a upcoming lecture. Now, what exact the difference between the compile time and the run time? Compile time, when we compile the code, at that time the particular function is compiled, that called the compile time, is also called early binding. And when the particular function is executed at the runtime, it's called late binding. Behavior of virtual function with the help of the late binding and early binding. This is simple, the code which only shows the both scenario is about late binding and early binding. Control save. It contains base class contains a two member function. One is a virtual and another is non-virtual. Then print is a virtual function, show is a non-virtual. Then derived class contains again a same overridden function of both print and show. Now we create a base class pointer bptr, and then again a derived class object, that one is a d. Then we copy the address of derived class object into the base class pointer. Now when we access the base class pointer with a particular function, and when we access the virtual function, it calls the derived class body. It is not called the base class definition of a function. That is actually the use, and that one is called at runtime, not a compile time, when we define any function as a virtual function. Then this is non-virtual function, it calls the body of the base class, and the output of this code is a print derived class and show base class. Print derived class and show base class. That one is simply the g++ 1.cpp -o1. Now that one is a compilation. At the compile, show function is compiled, because of that one is not a virtual. Now the print function is actually the called print derived class. When we call the print derived class, the body of the derived function is called, because of we define as a virtual, it refers a derived class function. Pointer refers a derived class function, and the show, when we call the show function, it calls a base class. It's a non-virtual, that's why it's called the base class body. It's a show base class. That is simply the difference. Late binding is done in the accordance with the content of pointer. Then late binding is called as a late binding. Print function calls a late binding or the late binding process, because of the virtual function. Show, that one is at the compile time, it's early binding. Now the next the use of the v table is a virtual table and the v pointer, virtual pointer. What exact the concept of virtual table and the virtual pointer under the virtual function? Working off, when we run with the virtual function, then these two new concepts comes. The use of these two concept, when we run the virtual function, it run at the runtime, and at the runtime we need to check it that one is run with the help of the virtual table and the virtual pointer. Now discuss here, if class contain a virtual function, then compiler itself does the two thing. If the particular class contains a virtual function, compiler execute the two steps. First step, object of that class is created. If object of that class is created, then virtual pointer is inserted as a data member of that class to point the virtual table of that class. Means when object of that virtual function class is created, it create the v pointer as a data member of that class, v pointer of the data member of that class, and it also create the v table. It also create the v table for the particular class, when we declare any function as a virtual function. When the object of that class is created, it automatically create the virtual pointer and also create the virtual table. This virtual pointer points to this virtual table, and this virtual pointer and virtual table is for a particular class. Each new object created, new virtual pointer is inserted as a data member of that class. Okay, if we create the one more object, then one more virtual pointer is created for a particular class as a data member. This one is the first step. It's automatically done by the compiler. If we define any function as a virtual function in a particular class, irrespective of object is created or it is not depend on object if object is not created but the function class contains the virtual function, the compiler creates the static array of a function pointer called as a v table. If we create the object or not, but the compiler creates a static array for that static array is called as a virtual table, and that virtual table is created for all the classes. If we define any base class as a virtual function, definitely the derived class run with the virtual table, individual virtual table. All the depend on the base class. If base class have the derived classes, definitely if we define a virtual function under the base class, all the derived class run with the virtual tables itself, the base class also. This is the base class virtual table. It contains the address of virtual functions. If it particular base class contains one virtual function, it stored the address of that. If it is 2, it stored the second address of second virtual function. Same thing, derived class also stored the address of virtual functions of that derived class, and that one is point with the virtual pointer of the each and every table. And why exact this one is happen when we use the virtual pointer? Because of at the time of runtime polymorphism, compiler verifies the pointer at the runtime which function is called. It's a base class virtual function or the derived class virtual function. It is depend on a logic, but that one is decided at the runtime. That's why these two tables, these two static array of a virtual table is very important. At the runtime, compiler decide which function is called. Now, this is simply the code which one is showing the difference between the runtime and the compile time accessing of a function, if it is mentioned as a virtual function or not. Then it's a simple output base 1. The base class contains one non-virtual function and 3 virtual function. Then derived class contains the one non-virtual function and 2 virtual function definition, or redundant function, we can say that. Now we create the base pointer as a p. We copy the address of derived class object in a p, and now we access all the function with the base pointer. When we access the function 1 contains under the both in a base class also in a derived class also, but it calls the base class body because of it is not a virtual function. It calls with the pointer of a base class. That's why it's called the body of the base class. That's why it's print the base 1. If it is a virtual, if we mention here virtual, it calls the derived one. Now p with the function 2. Function 2 is a virtual function. That's why it's called the derived function body. Derived function body of a function, that is it prints a derived 2. Now it calls the function 3. That function 3 definition is not available under the derived class. That's why it's automatically called the base class body. That's why it's print the base 3. Now virtual function 4 is called. That one is why it's called under the base class function, because of this one is a prototype is a different. This is the passing a variable, and this one is a normal function. That's why it verifies at the runtime this function body is called, not this one. Itself it is a virtual, but the prototype is not matching with the return passing parameter is not available in a calling. That's why it's called the base function. And all the function called, it's a function 2, 3 and 4 at the runtime, because of it's a virtual, and this one is at the compile time. When we this 2, 3, 4 function as a virtual function, this virtual table is used to store the address of the all the virtual function of the particular class. Then it contains both for base class also and for derived class also. And at the runtime, this pointer decides which function is called as per the logic, and this process is called as a runtime polymorphism, and it needs a virtual table and virtual pointer to decide at the runtime. Okay, this is simply the explanation about the virtual table and virtual pointer. Now we already know about when we create an object of the derived class, the compiler creates a pointer as a data member of the class containing the address of vtable of the derived class. That is simply that the runtime it decides it call the virtual function of derived class or the base class. That is simply the explanation about the virtual function with the virtual table and the virtual pointer. Now this is one more scenario about the virtual table and the virtual pointer. Base class pointer, it's a b1 b2, it points to the virtual function, virtual pointer. Virtual pointer contains the address of derived object, and it points a address of virtual function. Then virtual function address comes under the virtual table as per the class. This one is a base class pointer, this one is a base class virtual table. Same thing, derived class pointer and derived class virtual table also. vptr is a virtual pointer which points to the virtual function, for that object. vtable is a table containing the address of virtual function of each class, base class or a derived class. Both have a v pointer and vtable. At the runtime, it decides which function is called. It may be the virtual function from the derived class or the base class. This is simply the explanation about the vtable, v pointer and virtual function. Now it's important points to be remember. Only the base class method declaration need to a virtual keyword. Means if we define any function as a virtual function under the base class, then we can say that this one is a virtual function under the base class, and the derived class contains the same function, then we can say that it's a overridden function. If the function is declared as a virtual in a base class, it will be the virtual in all derived class. If we define any function under the base class as a virtual, then all the derived class contain that virtual function. It's also contain that function. It's also by default it's a virtual function. The address of virtual function is placed in a vtable. Address of virtual function, it may be the base class, it may be the derived class. That address of virtual function stored in a vtable of respectively the derived class vtable or the base class vtable. And a compiler uses a v pointer to point that virtual function. That is simply the explanation. All virtual functions contains run with the vtable and v pointer, and this concept or this vtable and v pointer initialized or created by the compiler because of the virtual keyword, and this one is going to happen because of the virtual keyword execute at the runtime. Virtual function execute at the runtime, and that polymorphism execute also a runtime. That's why it's called the runtime polymorphism. This is simply the explanation about the virtual function, virtual table, virtual pointer, which one is used under the runtime polymorphism. Thank you.